Hello, this is Dr. David Heber, and I really appreciate the invitation to speak to this fine group of scientists and other very informed folks about the topics of what we have learned in 2020 about immune function, about physical activity, and about overall health. I want to introduce myself as Professor Emeritus of Medicine and Public Health at the University of California, Los Angeles, where I was also the founding director of the UCLA Center for Human Nutrition in 1996. But my career spans over 40 years in nutrition, and I actually founded the Division of Clinical Nutrition in the 1980s, and I'm one of only 300 fellows of the American Society for Nutrition, which has only 300 fellows since the year 1950. I've trained many doctors and dietitians over the years and teach a class of undergraduates every year. So I've stayed at the cutting edge of nutrition. And it turns out that the most outstanding discovery of the last few decades has been the discovery of the microbiome, which has then opened up a great deal of new information about immunity, which we're going to discuss today. So first, I'm going to share my screen. Hold on one second, and we'll get there. There we are. So, immunity, obesity, and physical activity, learnings from 2020. You know, this has been a very difficult and challenging year with the worldwide pandemic, but we've learned a lot in the process about immunity, obesity, and physical activity. The field of immunonutrition includes nutrition, the microbiome, the 14 trillion bacteria in the gastrointestinal tract, genetics, and an understanding of inflammation. Much of the immune system is located in the gastrointestinal tract. And in the year 2014, together with my colleague, Dr. Bart Agarwal, I wrote a textbook called Immunonutrition: Interactions of Diet, Genetics, and Inflammation. So let's talk about the immune responses. It turns out that there are two phases to the immune response. The early response is called the innate response. It is relatively nonspecific. It basically releases inflammatory substances called cytokines. These are the same things that people feel when they have a reaction to a immunization with a flu vaccine or a shingles vaccine. And this results in some achy muscles, perhaps a slight fever, feelings of fatigue. These are all the results of cytokines released in the innate response. That lasts for a few days. However, after that, you start to develop what's called the adaptive response, and signals are sent to cells of the body that develop a specific response against the invader that's being the problem. And that occurs through the function of B cells, T cells, and plasma cells that produce specific antibodies. Now, there are two major ways that you can get an immune response. The first is active immunity, and that can happen either from natural infection with a pathogen or via vaccination. Passive immunity is when you achieve immunity, for instance, by getting monoclonal antibodies produced in cells in the laboratory, which are targeted against the pathogen. Also, babies can get maternal antibodies while they breastfeed and obtain immunity that way. So that's passive immunity. Now, how does the immune system develop? Well, early in life, it turns out that the baby, while they're breastfeeding, start to develop the immune system. And at the beginning, there's a single bacterial species called Bacteroides infantilis, which coats the entire surface of the intestinal tract, allowing the immune system, which lies below the surface of the intestinal epithelium, to start to develop specific immune responses. Cells called dendritic cells go to the surface and sense the different bacteria that may be coming in, or the antigens from food that may be coming in. It's not uncommon for young babies, for example, to develop a redness on their cheek when they first eat tomatoes that lasts for a few days. are eaten, the variety of bacteria in the GI tract also expands and becomes very diverse. These bacteria form communities, and the communities that form in each person are distinct based on your genetics and the diet that you eat. So a healthy gut has a lot of healthy bacteria that interact with the immune cells below the epithelium. These cells can tell foreign from normal. Now, if you have an altered gut environment, for example, if you have protein deficiency and this immune barrier gets broken, then bacteria can come under the surface of the epithelium in the intestine where they can set up inflammation. This is known as dysbiosis. Now, as people age, the microbiome becomes less diverse, and that in fact has a similar effect in promoting the risk for dysbiosis. So stress, diet, infections, vaccines, broad-spectrum antibiotics can all upset your microbiome. Now, diet and lifestyle also affect immune function. So a hectic, stressful lifestyle where people are eating fast food, energy-dense foods that have a lot of calories per bite but don't have much in the way of micronutrients can promote suboptimal nutritional status. Low income, lack of fresh, nutritious foods, a sedentary lifestyle and obesity, and a restricted diet can all lead to suboptimal nutritional status, which compromises immune function. Other factors include pollution and cigarette smoke, chronic stress, both physical and psychological. Abnormal sleep or sleep deprivation can also impair immune function by upsetting the biological clocks that maintain the normal rhythms of the microbiome as well as our various organs. Excess alcohol consumption is another factor, and prolonged excessive exercise leading to fatigue can actually compromise immune function, all of which increases the risk of infection. Now, body fat accumulating in the intra-abdominal area, which is very common in Asia, can lead to digestive imbalances, a leaky gut, dysbiosis, and various endocrine disrupting factors. Now, as you see in this slide, this young man has excess fat in the upper body. This excess fat grows very quickly, and it outgrows its blood supply, resulting in some of the fat cells dying and recruiting immune cells from the bone marrow. These immune cells, in the process of clearing out the dead fat cells, actually send an inflammatory message to the whole body through the release of inflammatory cytokines such as interleukin-6 and TNF-alpha. In addition to that, the adipocytes release certain hormones related to metabolism, including leptin, resistin, cortisol, and there are reduced levels of adiponectin. All of this affects immunity. So think of the abdominal fat as an immune organ that influences innate immune function as immune cells remodel excess abdominal fat. Now, one experiment in animals highlights this relationship. So that obesity in humans, we know, is associated with poorer health outcomes after infections compared with non-obese individuals. Memory T cells, these are the cells that remember the infection and its origin for a future immune response, reside in adipose tissue. And these are abundant even in lean mice. But diet-induced obesity, a high-fat, high-sugar diet, further increases memory T cell number in the adipose tissue and in the spleen. When these animals are re-challenged with a repeated infection, the memory T cells rapidly cause a severe increase in lipase levels, calcification of adipose tissue, pancreatitis, and reduced survival in obese mice, but not in lean mice. Thus, obesity leads to a unique form of viral pathogenesis involving memory T cell dependent adipocyte destruction and damage to other tissues due to the result of huge amounts of cytokines. In the human counterpart, this also occurs. Now let's talk some more about the microbiome and why it's so important. 99% of the genes in and on your body are from bacteria. There are only 23,000 human genes and about 2 million bacterial genes in the human body. The microbiome that we carry evolved to adapt to the human diet. It turns out that primates and other animals have very different microbiota. adapted to the diet that they eat. So the human microbiome is less diverse. And for people who eat a less diverse diet, their microbiome is even less diverse. Now, shown here on the slide is the microbiome in a single individual over a 1-year period. Each of the colorful bands represents a family of bacteria, such as Firmicutes or Bacteroides. Each of these may contain many species of bacteria. But what you can see is that there's a stable community over the year, except for one period where you see the green material. That's where the person had an intercurrent infection and they increased the number of proteobacteria in the microbiome. So the microbiome forms communities of bacteria. They're very stable. They are fed by the diet you eat, both fiber and other prebiotics, including phytonutrients from fruits and vegetables. And these bacteria also produce substances called postbiotics, which circulate around the body. Bacterial genes evolve rapidly in responses to changes in diet and changes in human metabolism because the bacteria reproduce much more quickly than even human cells. And a healthy microbiome supports immune function. Now, protein is very important for immunity because there is a protein barrier that separates the gut immune cells from the intestinal contents. That's shown here on the slide as the yellow band right above the epithelial cells of the intestinal villi. As shown on the right side of that, the crypt cells rapidly reproduce, move up to the tip of the villi, and then are extruded. And this happens every 6 hours. When there is protein deficiency, that barrier is broken down. Bacteria can enter the subepithelial space and cause immune reactions and food intolerance. So immunity against viruses can be lost with severe protein deficiency during starvation or during prolonged fasting. And infections and severe malnutrition are the most common cause of death, and they can be fatal primarily due to loss of immune function. Gut bacteria imbalance or loss of the protein barrier commonly leads to dysbiosis and inflammation. Now, higher protein intake is beneficial to maintain immune function and promote recovery in adults who are malnourished and fighting a viral infection. Studies also have shown that mice fed a protein-deficient diet reduced the size of their spleens, an important immune organ, and decreased the number of white blood cells that defend the body against infection, called T lymphocytes, compared to control mice fed a balanced chow diet. Now, with protein malnutrition, less of some critical immune proteins are made, including immunoglobulin antibodies that bind to viruses and prevent their entry into cells. Malnourished individuals getting inadequate protein in their diet also have a poor response to vaccines as the result of making less antibody. These reductions in immune cell number and protein malnutrition impair immune responses. Many population studies have shown loss of immune function during malnutrition, and this is generally accepted as a primary cause of death in malnourished populations. This explains the increased susceptibility to many kinds of infections in malnourished individuals, including infections with influenza, tuberculosis, bacterial and viral pneumonias, and gastrointestinal infections. Now, the body protein is extremely important. It is the most abundant substance in the body other than water, and it is a dynamic macronutrient. It is not stored like carbohydrate or fat, but is constantly being built up and broken down. When you eat a high protein meal, the protein is broken down in the digestive tract to amino acids. These amino acids enter the muscle where they stimulate muscle protein synthesis. Between meals, when you're not eating protein, muscle breaks down, releasing amino acids into the bloodstream, as shown on this slide. Now, exercise increases the ability of muscle cells to take up these amino acids and stimulate new protein synthesis. So as here where I'm doing my exercises, I'm creating a stretch across the muscle fibers, which will increase the amount of amino acids transported. Now, shown here are two aspects of this. First of all, a dose-response relationship. It turns out that you need to have between 20 and 30 grams of protein within 30 minutes to 1 hour after exercise to optimize new muscle protein synthesis. Exercise, as shown in the dotted lines in blue for older adults and green for young adults, further increases new muscle protein synthesis by increasing the uptake of amino acids. Now, there are many foods that promote immunity, including protein, which we've mentioned, vitamins and minerals, fiber, which helps feed the healthy microbiome, and polyphenols. And it turns out that polyphenols are also prebiotic, as we've discovered in our laboratory. So you want to eat nutrient-rich foods. Nutrient density, a concept developed by Dr. Adam Dronowski of the University of Washington School of Public Health, measures the amounts of nutrients versus calories in a food, so you can choose foods that meet your needs for balanced nutrition. Foods sold based on taste, cost, and convenience often provide too many calories with too few nutrients, which promotes overeating and obesity. Without providing needed protein, vitamins, minerals, fiber, and phytonutrients, these foods don't give you what your body needs. On the other hand, by focusing on the nutrients included in a meal rather than just the calories in a meal, you can improve your balanced nutrition and support a healthy, active lifestyle for optimum health and immune function. Now, fish oils are also very important for immunity. It turns out that with the Industrial Revolution and the development of processed food, oils are added commonly to snack foods and other processed foods. And these oils are often clarified during processing, which removes the omega-3 fatty acids, but leaves in place the omega-6 fatty acids in these polyunsaturated fats. So modern diet, unlike the ancient diet, has an excess of omega-6 fatty acids. Omega-3 fatty acids, on the other hand, are found in fish oils and fish oil supplements and are made by ocean-caught fish that swim at low temperatures. These fish oils, by balancing them with omega-6, can improve immune function. As shown on the slide, the omega-3 fatty acids and omega-6 fatty acids compete for the very same enzymes that elongate and desaturate these fatty acids, resulting in the production of either arachidonic acid, which is pro-inflammatory, a 20-carbon fatty acid, or icosapentaenoic acid, another 20-carbon fatty acid, which is anti-inflammatory. These two fatty acids are then converted by cyclooxygenase 2 into smaller molecules called prostaglandins, thromboxanes, and leukotrienes that control blood pressure, blood clotting, and breathing. And the balance of omega-6 and omega-3 is very important. So individuals can obtain this by eating a low-fat diet, thereby reducing omega-6, and then eating ocean-caught fish 3 times per week or taking fish oil supplements on a daily basis. Now, olive oil and avocado oil are neutral. They're what are known as omega-9 fatty acids. They are monounsaturated and do not compete with either the omega-6 or omega-3 fatty acids, but they still add 140 calories per tablespoon, so they should be used as needed to flavor foods and retain the heat in cooked foods. Now, your body fat reflects the fatty acids you've been eating in your diet. So studies of fat biopsies show that it takes about 2 years for the fatty acids in your body fat to reflect what you are eating. Now, many dietary supplements are also beneficial for immune function. Multivitamin, multimineral supplements with vitamins A, C, D, and E, and minerals zinc, selenium, iron, and copper support immunity. Fish oil supplements balance immune function, as we have said. Vitamin C defends immunity during cold season. Fiber supplements with soluble fibers and insoluble fibers support gut health and immunity. Phytonutrient antioxidants from fruits, vegetables, and spices like rosemary, acid, and schizandra support immune function. Now, vitamin D is extremely interesting. While often only associated with bone health, there's been increasing science around the effects of vitamin D on immune function. In the early 20th century, individuals who got tuberculosis of the skin would be sent to sanitaria and exposed to the sun, which then resulted in the synthesis of vitamin D in the skin and resolution of some of these tuberculous lesions. Now, it is known today that vitamin D also interacts with the gut microbiome. It also promotes immune system function through interactions directly with immune cells. And it crosses the blood-brain barrier, where it is beneficial in terms of inflammation in the brain. Now, it turns out that overweight and obesity, especially in individuals who have upper body fat or metabolic syndrome, is associated with vitamin D deficiency. Vitamin D, like vitamins A, D, E, and K, is in fact fat soluble. So for people who have excess body fat, the vitamin D will move into the fat tissue, resulting in lower blood levels of vitamin D. So vitamin D deficiency is found in surveys in up to 40 to 50% of populations around the world in association with metabolic syndrome, obesity, type 2 diabetes, and insulin resistance. Now, in the future, functional foods are a great tool to try to improve immune function in populations. Functional foods can enhance essential micronutrient intakes without adding unnecessary calories. They do this by concentrating the beneficial substances found in many foods. Foods for better health and reduced disease risk include functional personalized foods, phytonutrients from fruits and vegetables, and grains and spices and nuts represent the untapped scientific frontier of human nutrition with great potential for providing health in both foods and supplements. Research on nutrient bioavailability and digestibility, food safety, production costs, and consumer acceptance will determine the role of functional foods as main food sources in our post-pandemic world. Now, in this post-pandemic world, what's been highlighted is how personal health and public health interact. The power of public health actions by all of us against a global epidemic as individual actions add up. For example, obesity is now a global epidemic. Obesity and overweight combined with poor nutrition can have an impact on our immune function. Diet and physical activities are two modifiable risk factors that can help to reduce the incidence of obesity and overweight and indirectly improve immune function. Making healthier food choices and following a healthy, active lifestyle with good sleep and reduced stress all add up to fighting obesity and keeping your immune system healthy. And remember, individual health adds up to public health. So let's all do our part. Well, thank you very much for your attention. It's been a privilege to be included in this symposium. Thank you.